6179. The general circulation of air associated with a high-pressure area in the Northern Hemisphere is A. Inward, upward, and clockwise. B. Outward, downward, and clockwise. C. Outward, upward, and counterclockwise. The correct answer is B. When a high-pressure system forms in the Northern Hemisphere, it creates an area of relatively higher atmospheric pressure compared to its surroundings. This pressure gradient causes air to flow outward from the center of the high-pressure system. The air begins to diverge and move away from the central region. As the air moves away from the center, it experiences a downward motion towards the surface. This downward movement is a result of the descending branch of the Hadley cell, a large-scale atmospheric circulation pattern. The sinking air within the high-pressure system is due to its increased stability, which inhibits vertical convection and promotes subsidence. Additionally, the Coriolis effect, caused by the Earth's rotation, influences the direction of airflow. In the Northern Hemisphere, the Coriolis force deflects the moving air to the right. As a result, the air within a high-pressure system in the Northern Hemisphere rotates in a clockwise direction around the center. This overall circulation pattern is often referred to as anticyclonic flow. It is characterized by air moving outward, descending towards the surface, and rotating clockwise. This circulation leads to generally clear skies, light winds, and stable weather conditions commonly associated with high-pressure systems. 6180. Which statement is true regarding high or low-pressure systems? A. A high-pressure area or ridge is an area of rising air. B. A low-pressure area or trough is an area of rising air. C. A high-pressure area is a trough of descending air. The correct answer is B. In meteorology, high and low-pressure systems refer to areas of varying atmospheric pressure relative to their surroundings. These systems play a crucial role in weather patterns and the overall circulation of the atmosphere. A low-pressure area, often referred to as a trough, is characterized by lower atmospheric pressure compared to its surroundings. It occurs when air near the surface rises, creating a vertical motion known as ascent. As the air rises, it cools and condenses, leading to cloud formation and potential precipitation. Low-pressure systems are typically associated with unstable atmospheric conditions and the development of weather phenomena such as rain, thunderstorms, or cyclones. Air converges into low-pressure areas near the surface, ascends, and diverges aloft. Conversely, a high-pressure area, also called a ridge, is characterized by higher atmospheric pressure compared to its surroundings. In a high-pressure system, air descends from higher altitudes towards the surface, resulting in a vertical motion known as subsidence. As the air sinks, it warms and inhibits cloud formation, leading to clear skies and stable weather conditions. High-pressure systems are often associated with fair weather, light winds, and less likelihood of significant weather disturbances. Air diverges near the surface, descends, and converges aloft. It's important to note that low and high-pressure systems are integral parts of atmospheric circulation. In the Northern Hemisphere, air flows counterclockwise around low-pressure systems and clockwise around high-pressure systems, following the principles of the Coriolis effect. In the Southern Hemisphere, the airflow is reversed, with low-pressure systems exhibiting clockwise rotation and high-pressure systems showing counterclockwise rotation. The movement and interaction of these pressure systems, along with other atmospheric factors, contribute to the formation and evolution of weather patterns on various scales, ranging from local weather phenomena to larger-scale weather systems and global climate patterns. 6181, which is an operational consideration regarding actual air temperature and dew point temperature spread. A. The temperature spread decreases as the relative humidity decreases. B. The temperature spread decreases as the relative humidity increases. C. The temperature spread increases as the relative humidity increases. The correct answer is B. The temperature spread refers to the difference or gap between the actual air temperature and the dew point temperature. The dew point temperature is the temperature at which the air becomes saturated with water vapor, leading to the formation of dew or condensation. The larger the temperature spread, the drier the air, indicating a lower relative humidity. When the relative humidity increases, it signifies that the air is holding a higher amount of moisture relative to its capacity. As the amount of water vapor in the air increases, the dew point temperature also rises. Consequently, the dew point temperature becomes closer to the actual air temperature. In simpler terms, as the relative humidity increases, the air becomes more saturated with moisture. This results in a smaller temperature spread between the actual air temperature and the dew point temperature. Conversely, when the relative humidity is lower, the air can hold less moisture, causing a larger temperature spread. 6182. The ratio of the existing water vapor in the air, as compared to the maximum amount that could exist at a given temperature, is called A. The dew point, B. Saturation point, C. Relative humidity. The correct answer is C. Relative humidity is a crucial metric used to assess the moisture content of the air. It represents the ratio of the actual amount of water vapor present in the air to the maximum amount of water vapor that could exist at a specific temperature, expressed as a percentage. Relative humidity is influenced by both the air temperature and the amount of moisture in the air. Warmer air has the ability to hold more water vapor than colder air. Thus, the maximum amount of water vapor that the air can hold increases with higher temperatures. The calculation of relative humidity involves comparing the actual water vapor content in the air to the maximum water vapor capacity at that temperature. This comparison is made by dividing the actual water vapor pressure by the saturated water vapor pressure at that temperature and multiplying the result by 100 to obtain a percentage. If the relative humidity is 100%, it means the air is holding the maximum amount of water vapor it can at that temperature, and it is considered saturated. Lower relative humidity values indicate that the air has the capacity to hold more moisture, while higher values suggest the air is close to reaching its saturation point. Understanding relative humidity is essential in various applications, such as weather forecasting, agriculture, HVAC systems, and determining human comfort levels. It helps in assessing the likelihood of precipitation, predicting fog or dew formation, understanding evaporation rates, and providing insights into how humans perceive temperature. In summary, relative humidity refers to the ratio of the actual amount of water vapor present in the air to the maximum amount of water vapor the air can hold at a given temperature. It is a crucial factor in understanding and analyzing atmospheric moisture conditions. 6185. When warm air moves over a cold lake, what weather phenomenon is likely to occur on the leeward side of the lake? A. Fog, B. Showers, C. Cloudiness. The correct answer is A. When warm air moves over a cold lake, a weather phenomenon that is likely to occur on the leeward side of the lake is fog. This occurrence is known as lake effect fog. When warm, moisture-laden air encounters a cold surface, such as a cold lake, the air near the surface undergoes rapid cooling. As the warm air comes into contact with the cold water, heat is transferred from the air to the water, causing the lower layers of the air to cool. As the air cools, it reaches a point where its temperature matches the dew point temperature. The dew point temperature is the temperature at which the air becomes saturated with moisture and condensation begins to occur. When this happens, the excess moisture in the air condenses into tiny water droplets or ice crystals, forming fog. Fog is essentially a cloud that forms at or near the ground level. It consists of numerous tiny water droplets suspended in the air, reducing visibility and creating a hazy or misty appearance. The formation of fog is facilitated by the temperature difference between the warm, moisture-laden air and the cold lake surface. On the leeward side of the lake, which is the downwind side opposite to the direction of the prevailing wind, the cooled and moisture-laden air mass moves away from the lake. As the air continues to cool and reach its dew point, fog forms in the vicinity of the lake and extends over the adjacent land areas. Lake effect fog can persist for varying durations, depending on factors such as the temperature difference between the air and the lake, the wind speed and direction, and the characteristics of the lake itself. It tends to dissipate as the temperature and moisture conditions equalize or if the wind patterns change. In summary, when warm air passes over a cold lake, the temperature contrast leads to the cooling of the air near the surface. As the air reaches its dew point temperature, fog forms, resulting in reduced visibility and a hazy appearance. This weather phenomenon, known as lake effect fog, occurs on the leeward side of the lake.